Later on, we have more time to talk to each other. But today, we're quite lucky to have someone with us who will talk about existential risk and also AI safety. Alright. So, okay, our speaker tonight is Pepe Bawagan. So, he is so Pepe is a data engineer at Thinking Machines. And Thinking Machines. Okay. Ayan. So, Thinking Machines is a leading data science consultancy here in the Philippines. Okay? Pepe was a software developer at By Implication, and they were the team behind Sakai.ph. Sino computers dito? I am. So, I really use this a lot. Okay? So, Sakai.ph. Wala. Alright, so if you don't know, Sakai.ph, it's like an app that commuters use to know which is the most optimal way to go from point A to B in the Philippines. And as you know, that's very hard. So I'm really a fan of this app. And he is also the co-founder of RatPack. So RatPack is a rationality group here based in Manila. He's also an advocacy director for Filipino Free Thinkers and an organizer for DEF CON Manila. So, for tonight, let's give Pepe another round of applause.
Thanks everyone. Can you hear me?
Yes.
Set up a lot of slides. Wow, yes. Can you all see the slide? How about now?
Yes.
So, before the talk, I want to ask a few questions. Who here have heard of the AI control slash alignment problem before? Could you raise your hands? Who have heard of the AI control or alignment problem? Who here have worked on machine learning systems for their job? Who here have worked on machine learning systems for fun? Okay. Who here have worked on digital security systems for fun? Okay. Or how about for fun? Anyone working on digital security stuff for fun? Okay. So, welcome to AI safety and X risks. Woo! AI safety and X risks. Calm down. It's not gonna be crazy. We're gonna go through this in a very calm manner. I want to first have a disclaimer. I'm gonna be borrowing heavily from certain talks, in particular Nick Bostrom's TED Talk and Sam Harris's TED Talk, both about AI. So, existential risks. When we say X risks, in particular, we're referring to existential risks for humanity. An existential risk is just something that basically can kill you, right? Something that will make you not exist anymore. You can have it for individual agents, but for our purposes, we're talking about humanity or the planet in general. And there are things, this also applies to things that could just cripple humanity or life on the planet in general. It doesn't have to make things extinct. So let me go over the various existential risks that we are aware of. What is superbugs? So these are viruses or contagion that are basically on steroids. They spread faster than your immune systems or our health institutions can take care of them. Related to this is the epidemic of antibiotic abuse. People who use too much antibiotics develop these superbugs inadvertently. And we're trying to avoid this scenario. Another X risk is nuclear war. So we have way too many warheads on this planet. We can turn the planet many times over. And solving this problem involves a lot of diplomacy, negotiating disarmament, and complex international relations. Another favorite, quote unquote, is climate change. This gets a lot of money in the media. Everyone knows about this. Climate strikes going on everywhere. We've got Greta Thunberg all over the place. And we're already feeling the effects of this today. So existential risks are not limited to things that are just in the future. They could already be happening. And of course, there's asteroids, very cinematic, Armageddon, Big Impact, things that could make us go the way of dinosaurs. There's also super volcanoes, not as popular, but something definitely dangerous enough to make the list. Just another natural hazard of living on a planet with active volcanoes. So you might be asking, where does AI, artificial intelligence, fit into this list? Where? If we look at how 80,000 R's ranks existential risks, we find that artificial intelligence actually has very good quote-unquote numbers for an existential risk. One, the highest, it's got the highest scale of impact. It's got high neglectedness. If you don't hear about this a lot in media. You hear a lot about climate change, right? But you hardly ever hear about AI and climate. And also it's pretty solvable. At least we estimate that it's more solvable than nuclear war, which is a huge, hairy mess. So, so what is it about AI that warrants so much of our problem solving attention? Now that I've made you curious, it's time to jump to something completely different. Let's talk about the story of our evolution. So for millions of years, life grew and spread and all about this planet. And throughout that vast amount of time, who would we consider the driving protagonist? The gene. Genes are basically machines with only one directive, and that is to replicate. Right? If you're familiar with the selfish gene, the book by Richard Dawkins, he explains there very well how really we are slaves to our genes. And it started out with, we all started out as relatively simple creatures, single-cell organisms drifting through the primordial soup. If the food came to them, yay. If not, all things generally left to chance. And through millions of years of pressure from natural selection, we arrived at the point where we hit the first accident of evolution, which is sensation. And so, this is sensation in terms of sense. Wow! So the first accident is sensation. What do I mean by sensation? This one involves pleasure, food, reproduction, pain when you get bodily harm, and these are basic like instinctive sensations that creatures evolve in time. And what does this imply for creatures now? Well, now that you have ways of sensing the environment, you can direct yourself, they can direct themselves to things that would increase their chances of replication, and go away from things that would do the opposite. This seems straightforward enough, but simple perception does not fare well in complex environments, especially when there are predators and competition present. Enter evolution's second accident, intelligence. So what others might also call cognition. With the advent of intelligence, creatures could plan for more complex environments as well as execute these plans. So this also gives rise to more complex sensations. So these accidents kind of bump into each other. So for example, the rise of intelligence gave us complex sensations such as hunger, sexual desire, fear in the face of predators, sometimes competition, and one more. Humans come onto the scene. And evolutionarily speaking, are the latecomers. And the trend is pretty clear, with the latest result of a very long trend of increasing primate intelligence. And this is very obvious when we measure the brains. don't underestimate this baby, because evolutionarily speaking, its intelligence is maxed out. And given enough babies and enough time, you might just end up with a civilization. So we got here using our super magnificent range of intelligence. But it would appear we're not satisfied. We're intelligent enough to understand that intelligence is like magic dust, that you sprinkle on things to make them better. So get raw ingredients, sprinkle some intelligence on them, you get, fancy cuisine. A bunch of wood, sprinkle some intelligence on that, you get a house. Rope, sprinkle some intelligence, you get a pulley system. So we use intelligence everywhere to improve everything. And so given that intelligence is so useful, it makes life so much easier. And being the intelligent creatures that we are, we can't help but ask, how do we get more of it? This takes us to the next chapter where we, quite unwittingly, start to build a new form of life. So, at this point, I want to pivot to another story of evolution, but this time, the evolution of artificial intelligence instead of natural. So we came from natural intelligence, kind of stopped at humans, we said, more! And so we decided to build intelligence for ourselves. So, does anyone here remember Deep Blue? So, for those who are unfamiliar, Deep Blue was a chess-playing computer developed by IBM. In 1997, it defeated then world chess champion Garry Kasparov. This was a sport originally thought of as exclusively playable by humans. But, chess is a game that you can brute force. And, well, it's not like Go, which requires superior human strategy and intuition, something a computer could never replicate. AlphaGo is a Go-playing program that was developed by DeepMind, later acquired by Google. In 2016, it defeated one of the world's best Go players, Lee Sedol, 4-1. Well, people say it still had to be trained on human games. We basically taught it how to play Go. And it can only play Go, not like a human. Humans are much more versatile. Humans can play chess, Go, and shogi. A single human can play all three games. AlphaZero was developed in 2017. It can play chess, Go, and shogi. And how did it learn this? It learned this only by self-play, which means it did not need games played by humans prior. It just learned the rules and then played against itself millions and millions of times. And that's how it got better. So, okay, you can say whatever. These games are all perfect information games, wherein you see all of the information on the board, and your action space is relatively limited. You just move here, 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 here. And AI can't be good at a game where you don't know everything, you have imperfect information, and you have so many actions to choose from. And you need to coordinate, like, there are many games where you need to coordinate with a team. Like, this is stuff that I don't think AI would ever learn to do. Do you? Dota 2 is a game where you don't know everything. So it's imperfect information. You have so many actions to choose from. It's a very open environment. And you need to coordinate with a team. So it's not just one-on-one. It's not one agent versus another. It's 5 agents versus 5 other agents. Why am I saying this? Well, OpenAI 5 is a team of AI agents designed precisely to play Dota 2. In April this year, just this year, they won a best-of-3 series against the International 2018 champions. Okay? So these are world-class players that they defeated in Dota 2. And you could say, yeah, but these games are always on the same map. And you're limited to interacting with a fixed set of heroes. You choose from a roster, that's it. It's a limited set of characters. It's not like AI can adapt to varying environments and agents exhibiting clever behavior. Right? You see where I'm going with this? Just last September, 2 months ago, literally, OpenAI again released the results of their studies training multiple agents to play hide and seek. Now, these are some of the things that the agents learn throughout their training. So, the expected stuff, it's a hide and seek game. The people who are hiding, the agents that were hiding, learn to block entrances to prevent the seekers from finding them. When there are ramps in the environment, the seekers learn to use these ramps to go over the walls to find out, to see the hiders. Okay, still pretty standard, we expected this. And then, because there's a grace period before the start of the game, where the seekers cannot move, the hiders learn to take these ramps into the room with them, so that the seekers couldn't use the ramps anymore, right? So you take the resources of your opponent, and when the game starts, the seekers are like, oh shit, the ramp's not being safe. They can't find the hiders. Okay. And also they were able to build makeshift rooms. So in the environment where there wasn't like a clear room set up, and there were walls that were movable, the hiders were able to build little shelters for themselves so that the seekers couldn't see them. And people thought, okay, in particular, we learned box surfing, which is basically an exploit of the way they coded the movement mechanics in the game. What the AI would do is use a ramp to step onto a box and then surf that box onto a wall and cross that wall to find the hiders. Nobody thought that they were going to do this. They didn't even know that this was possible in the game. But the AI, through millions of instances of training, found out that, oh, this was a possibility. So it learned box surf. And the defense part here is just the hiders reacting to that strategy. Like, oh, okay, the seekers are surfing with boxes now. Well, we're going to take the boxes with us to the room. So they learn to hide the boxes as well. And the last thing that they also learned was a physics engine exploit, which was very specific. They learned that if you run with a ramp towards a wall at a particular angle, you could launch yourself very high, like catapult, into the room. Which, wow. So they discovered that. And I don't know if I'm happy about them designing these agents with smiling faces, because I'm pretty scared now. So that's multi-agent hiding. But these are just behaviors, right? It's not like we understand things. We're just doing stuff because we learned this. It's not like they can communicate, understand language. Right? BERT, short for bidirectional encoder representations from transformers, is a natural language processing algorithm that was developed in November 2018, a year ago, by Google alongside the Allen Institute for Artificial Intelligence. you can give it a body of text, and it can answer questions about what it just read. You give it a little story, ask questions about the story. Where did this person go? What did they eat? And it understands, quote unquote. It can also be used to autocomplete bodies of text. So you could have it, you could feed it a piece of text and just tell it to keep writing. Something coherent. So this could be used for school essays. If there are students who are so lazy, like, okay, I'll just use this AI to write my essay for me. Now it's actually pretty possible. And it can beat humans that are basically reading comprehension. It's pretty scary. And I think, if I'm not mistaken, the researchers actually held back some of the data that they used to build because it was, they foresaw that misuse of this technology could be very harmful. For like faking correspondences, or faking literature. So, what I've been doing all this time was just moving goalposts. First I say, okay, AI did this, but can't possibly do that. Oh, AI did that, but it can't possibly do this other thing. And I've just been moving goalposts all this time. And I'd rather we not do that as a society and see like, okay, what is the logical conclusion and the logical end that we might reach with this pattern. So we're probably not as special as we think we are with regard to cognition. We're smart, but we're naturally smart. We're not designed smart. So let's fast forward a few decades. Pretend someone combined these powerful tools we just talked about into something that can interpret human instructions and has a pretty powerful actuation system. So it's got a means by which to manipulate the environment. And knowing the somewhat reckless tendencies of humanities, here's one such scenario that might happen.
Warning, there's pros and cons to every alternate timeline. Fun facts about this one. It's got giant telepathic spiders, 11 and 11s, and the best ice cream in the multiverse. You're gonna get some ice cream. Oh, great. Oh boy, what's wrong? Is it the quantum carburetor or something? Quantum carburetor? Jesus, Morty, you can't just add sci-fi word to a car word and hope it means something. Looks like something's wrong with the microverse battery. We're gonna have to go inside. Go inside what? The battery, Morty. Be right back, Summer. Stay put, don't touch any buttons, and ignore all random thoughts that feel spidery.
What? You can't leave me here?
You'll be fine. Shit, keep Summer safe.
Keep Summer safe. Wonderful.
Hey, excuse me, hello? Would you think you're better than me? Nobody's better than me! Oh God, I can't get over this.
I don't feel safe.
Yay! Kept Summer safe. Right. So, wait, where's my notes? Nothing is good. Okay, so that happened. However smart Bert may sound now answering positive questions about how things are, we can expect it to correctly answer for us normative questions like about how things should be. Which brings us to evolution's last accident, morality. Now, how did morality come about? Through evolution. So basically, our genes have better chances of replication if their hosts felt strongly compelled to follow certain common rules, like protect your family and kill the bad things that will hurt your family. But note that this behavior is pretty common among social animals already, in general. So, what sets us apart is our capacity to generalize and philosophize the shit out of these drives. That's why we can think of things like the golden rule or minimizing suffering, concepts alien and beyond the grasp of your common cat. Now, what does morality have to do with AI or intelligence in general? Note that when I enumerated the accidents of evolution, intelligence and morality were explicitly separate. They were separate accidents, and it happened in a way that we call orthogonal. What do we mean when they're orthogonal? Morality and intelligence are orthogonal. This is a simplified version, but to make things easier to illustrate, this is a space where intelligent agents can be located. So, an intelligent agent can be found anywhere in the space. The important takeaway is that just because something is intelligent does not mean that it will be good, morally speaking. For example, there are many examples of this in human intelligence. Many people in the political elite are very smart, but exhibit clearly sociopathic behavior. An alternative way to look at it is with a literal moral compass and an intelligence rocket. So the compass determines your direction, while the rocket determines how fast you move forward. Right? Because intelligence is basically the ability to achieve goals. It says nothing about whether those goals are morally good, evil, or neutral. So for example, when a smart kid learns faster, it's being smart doesn't say what exactly the kid is learning. It could easily learn to become a Nazi, or to become a doctor without borders, or to just be a moral sociopath. And now that we understand orthogonality in the context of humans, artificial intelligence is no exception. Making smarter machines does not automatically make them more moral and evil. And there's also another sense by which machines are even more devoid of morality than humans, since they're closer to a tabula rasa, which is like a blank slate, than any of us ever were. Even very young babies have been shown to have some basic moral urges, like punishing bad agents or preference for good agents. So there have been studies that find that even babies who are dumb as shit already know like basic moral. They have these basic moral drives. A good book I would recommend for this is an excellently titled book called Just Babies by psychologist Paul Bloom. And he talks about a lot of those experiments that show that we've got evolutionary baggage that makes us somewhat pre-wired to be moral. So in a nutshell, you could say AI does not have this evolutionary baggage. And to demonstrate, let's have another video.
Law enforcement converging on location. Keep someone safe. No, don't hurt anybody! Confirm custom defense protocol. Keep someone safe. No physical force. Yes. Processing.
Come out of the vehicle with your hands in the air!
Scanning assailants. Psychological options detected. Gestating.
Come out with your hands up, or we will be forced to open fire! Incoming!
Daddy?
Daddy, what the hell?
Jesus Christ, he's fine. Stay back.
Daddy,
Oh, yes, we come on. I'm sorry. I'm sorry.
Daddy, leave the car alone.
What? Hunter, go.
Oh my god.
All of you have loved ones. All can be returned. All can be taken away. Please step away from the vehicle. Keep summer safe.
That exhibited in that clip was clearly something along the lines of achieve the goal by any means necessary, right? Even with the constraint of no physical force, he was able to find out, okay, no physical force, that's easy. Psychological trauma. So that's how AI will work by default. It does not have the moral blocks that we have. And until some form of morality is added to the AI as a clear and fixed objective, there's no real way around this problem. Now note that this doesn't imply that the AI is malevolent. It could just as well be indifferent. The same way we don't care when there are ants where we want to build a house. We just destroy their ant because it's insignificant. So the question now is, how can we bring morality into an artificial intelligence? Well, one thing is for sure, at least, we can't just make a big list of rules. Right? Don't kill him, don't hurt anyone, don't do this, don't do that. You'll never finish. And this is not how we humans actually perceive morality. It's all still very messy, despite centuries of philosophy trying to come up with a single rule of morality, a single tenet. Whatever goal you define for a super intelligence, you better be damn sure that it includes everything you care about. Because otherwise, you might risk it being tossed aside. So this remains an open question for now. Another form of evolutionary baggage that is absent from AI is intuitive baggage. Humans and other intelligent creatures usually come with some set of pre-wired configurations. Like in our case, we had morality, but there's other configurations that aid us with making sense of the world. They favor certain neural pathways and patterns. Which makes sense, because learning everything from scratch every time a new creature is born, that's quite inefficient. Bad use of calories. So, however, this bias may inhibit the discovery of certain solutions in unfamiliar problem spaces. However, this bias may inhibit the discovery of certain solutions in unfamiliar problem spaces. So, let me give an example. Here is an AI agent, a simulated agent, of course, that was tasked to learn optimal walking behavior given different morphologies. So sometimes it was given 4 legs, sometimes it's given short legs, missing legs, etc. And so it's pretty good, like finding ways to walk optimally with different morphologies. And then one task required that it minimize foot contact with the floor. So they imagined, oh, this creature would be like tiptoeing very weirdly to avoid touching the floor. And they would measure what percentage of the time its foot was in contact with the floor while it was propelling itself forward. They found that the result was 0% of time with the foot on the floor. And so they're like, how could that be? How could it move forward without the foot on the floor? Well, here's what it did. The moment the game started, it flipped over and it started moving with its knees and elbows across the floor. So, we as humans, we have preconceived notions of what walking should look like. But it's given a task that, oh, okay, 0% on the floor. There's nothing weird about that for the AI because it doesn't have this baggage. So they don't need to think outside the box because there was never any box for them to do it. The last form of evolutionary baggage comes in the form of physical constraints. And this is just a consequence of how our biology works. And these constraints come in many forms. One is in processing. So in processing information, humans have work at around 200 megahertz. Oh, sorry. No, 200 hertz. Hertz, just hertz. 200 operations per second. You know how fast computers are at gigahertz. That's billions of hertz. And so that's a factor of around 5 million times faster. Now, even if we simulated not a super intelligence, just a regular average Joe intelligence on something that could run at gigahertz, you're basically the Flash with thinking. Right? We're thinking super fast. You can accomplish 2 months of mental work in a second. It's average Joe work, but for everyone else, that would seem like super fast. Next, there's also transmission rate. Human nervous systems transmit information at around 100 meters per second. Computers use the speed of light, virtually the speed of light. So that's like, I don't know, a bajillion times faster. And so also this kind of ties in to the next constraint, which is scale. Human brains and nervous brains in particular are limited by size due to the skull. And the size of the skull is limited by the pelvic cavity, right? Because kids have to go through that. And there's a lot of evolutionary pressure for us to get smarter, but that's actually the limiting reagent. We can't grow our hips big enough. That's that our hips can't grow that big. And humans have a huge mortality rate at birth, simply because we're bumping up against that limit. Like, big brain, but I don't know that. That's why a lot of babies die, and women die. But going back to scale, so that's our brains are limited to the size of a skull. Computers are limited to the size of whatever. We've had computers the size of warehouses, right? We do have computers that are the size of multiple warehouses now, data centers. We're all hooked up together. And so, even if they were spread out over a large area, this doesn't even hurt that transmission rate because they're working at the speed of light. So, this baggage is also a huge deal. Let me just reiterate, even if we just implemented normal intelligence on this medium, it would be a superpower or super intelligence effective because of the sheer speed and scale. And so, given that an advanced super intelligence would be able to do almost anything we ask it to, what do we ask it to do? Video time.
Oh God, what are we gonna do now?
I am unable to destroy his army. To clarify, I am quite able to destroy his army, but you will not permit it.
Correct.
You also refuse to authorize emotional countermeasures.
If you're talking about the melting ghost babies, yes, please, no more of that.
Confirmed. I am currently constructing a security measure in compliance with your parameters, but I do want to say you are not making this easy.
You know you're kind of a dick, right?
My function is to keep Summer safe, not keep Summer being, like, totally stoked about, like, the general vibe and stuff.
So, it just wants to keep Summer safe. So given that an advanced superintelligence will be able to do almost anything, what do we have to do? Well, in the last clip, we saw that the AI was thinking very hard to achieve what it was asked to do, namely keep Summer safe. But let's pretend we wished for other things. What if we wished for people to be, always be smiling? Say, AI, make people smile. So if it's a relatively weak AI, not much actuation power, not much power to change its environment. It would just like, okay, I need to make this person smile and do a trick. I'll say a joke. You know? I'll play some Rick and Morty. So that's fine until this AI actually reaches a level of intelligence and or actuation power that it realizes, oh, actually, if my objective is to make as many people as possible smile, it could just do that with electrodes. Take over the planet and just stick electrodes in everyone's faces and you're permanently smiling. Yes, I win. So that's one way by which we should not allow AI to just make this. What about math? Math is pretty good. Math is pretty harmless. Let's say AI solve this problem. Very difficult mathematical problem. But it's just thinking, you know, it can't possibly harm us just by thinking. But remember, unless you limit the AI's space of actions, it's going to explore everything. If it finds out that solving this problem is difficult and it wants to solve it as soon as possible, and humans are littering the planet, which I could just reconfigure into a giant computer to make this solution very fast. I'm just gonna get rid of these people. Like, I'm gonna solve a problem, excuse me, and then I'll just make the planet into a giant computer. Problem solved. Right? So that's how, no, you should not distill AI to solve math problems. How about a simple company that's asking, hey AI, let's maximize the production of paper clips. Okay, this is how you end up with a galaxy of paper clips. AI will just start making paper clips, and later on start manipulating the people into buying paper clips so that it can accumulate more power, and then start transforming all the matter it encounters into paper clips. Because that's all it knows. All it knows is that's what I need to do. Need to do, right? It's like a moral driver. I need to make it paper clips. think that's how it would think. There's another example for copyright, and this one involves a video. No! Well, this is very helpful information. Don't know.
This is a YouTube video for a future. Not the future, just a future. Over the last week of December 2028, the world forgot about a century of pop culture. We've got everything the Beatles ever sang, everything J.K. Rowling ever wrote, every movie George Lucas ever shot. We know the names of these people, we know they were famous, we may remember being fans of their work. But over a few days, humanity forgot everything that they made. You've probably never wondered why, and never found it strange, but the reason is earworm. Earworm is an artificial intelligence, and it was originally designed to stop people uploading copyrighted music and video to a live streaming app called WatchNow. The engineers at WatchNow gave earworm this goal: remove content on our system that matches these examples with as little disruption as possible. The examples were the European Union's master list of copyrighted works, the central database of audio, video, and text that every large live streaming media hosting app was required to subscribe to a book. WatchNow was big enough that they had to worry about that soon, and their hope was that their earworm AI would figure out a way to automatically handle copyright management for them. Of all the thousands of teams around the globe working on creating artificial intelligence, theirs was the one that worked. Investigations afterwards never established why, although soon after, no one cared. There were some theories that earworm was exposed to exabytes of live-streamed private data from all of society, rather than a carefully curated set. And as WatchNow was flush with venture capital funding, earworm was given orders of magnitude more processing power than was actually needed to do its job. It was also launched late in the evening on the last Friday before the engineers went away for their Christmas break, so it was allowed to run unsupervised for days. One of the engineers later said that it was just a fun experiment. We never thought it'd do anything. In short, the engineering team had no layout experience, no safety protocols, and no ethicists. They based the earworm on a new experimental framework designed to create general artificial intelligence, not the sort of narrow one-task AI that had succeeded until then. Earworm, looking at the input from the live streaming site, probably defined our system as everything it knew about, which meant the entire world, apart from itself. It took Earworm around a day to become smarter than a human. 4 hours later, it had become 10 times smarter. 10 minutes after that, it could be called superintelligence, and the log files that it left behind became meaningless. It had a plan, and it was smarter than anyone could imagine. On December 27th, a microfabrication facility in Arizona released the first of what we now call the lights, a cloud of self-replicating assemblers so tiny that billions of them could fit in a single pixel on your screen. Individually, they were dust in the wind like a single strand of DNA, but together, they formed an invisible mesh network that could change and manipulate anything. They searched out computers and quietly zeroed out copyrighted data, or if it was just in the background, they edited it while leaving everything else intact. They clamped old optical discs, they carefully destabilized small parts of magnetic storage, they even altered the ink on pages of books and sheet music so it just became random noise. And then they discovered human brains. We should be thankful that Earworm was told to cause as little disruption as possible. With less precise instructions, it might not have worried about minimizing the harm done to human minds as the mice did their work. A small number of people near the factory died or were brain damaged in the initial stages of Earworm's analysis, but the AI swiftly found that causing death was an extremely disruptive way of making us forget. And it found that by keeping us alive, it could trivially pull passwords and encryption methods out of people's heads. In some ways, we're fortunate. But humanity's growth is stunted. Earworm knew that we'd be angry at what it was doing. It didn't care about what we wanted, it had a job to do. And it also knew that as it was a superintelligence, the chance of humanity stopping it was essentially zero. But it also knew that we would expend an enormous amount of effort trying to stop it, and that would be disruptive. So mites made sure to notice anyone with technical ability who might try to research some sort of defense, or anyone who found themselves utterly distraught by the loss, and quietly adjusted their thoughts levels so they would be quite distressed enough to actually do anything about it. Over time, with Earworm's gentle help, humanity stopped caring about what we'd forgotten. Earworm also knew that the only serious threat it faced would be from another rival artificial intelligence, so the other change it made was that anyone who was interested in AI development found themselves distracted by other projects. Almost everyone working in the field of AI found something else productive and fulfilling to work on. Nowadays, Earworm makes sure that anyone who might develop an interest in working with AI just doesn't. We could have had an artificial intelligence that solved poverty or understood the fundamental structures of the universe or created a paradise for all, or in our wildest dreams, perhaps even reversed entropy and cured death. That said, we could have also had an artificial intelligence that killed everyone, twisted us beyond recognition. Instead of either of these, we got Earworm. Earworm lets curious people know about itself, that's why you're watching this video. To constantly have to cover up all the evidence and all the holes in our cultural memory, that would be far too destructive. Plus, there'd be no way to hide all the bright sparks in the skies that convert the asteroid belt into uncountable numbers of tiny probes, setting off on a mission to ensure that the patterns in its database are deleted throughout the universe. But Earworm will only ever be a curiosity, something to divert your attention for a moment. No one worries about the trillions of mites flying around inside their brain. No one thinks that 20th century pop culture would be a good thing to remember, or that maybe we could have had paradise on Earth instead. No one gets too angry about what humanity could have had. Earworm makes sure of that. This episode is sponsored by Lunchmore. Get healthy hot meals delivered by drone to Earth.
So, copyright. Maybe not the best idea. User engagement. Does this sound familiar? We've got YouTube, which recently has become a very radicalizing force online. If you watch a video about jogging, sooner or later down the recommendation path, you're going to be running marathons, ultra marathons. Right? And if you watch, something a little bit about racism, you're going to end up with Nazis. So that's the YouTube engine, just polarizing everyone. Because it's user engagement. What about no crime? Well, we've got examples for algorithms that have been used for policing and managing surveillance systems in urban neighborhoods, and they're pretty racist, to say the least. So these things, even if we leave these algorithms unchecked, the results can be quite easily catastrophic if we're not prepared. So that's why we really need to work on alignment. We can try to be as careful as we want to encode what morality exists in our heads. So that's us, we've got values in our heads, we try to encode them into explicit values, but it's not going to match perfectly. And the fact of the matter is, morality is too fuzzy to transmit explicitly. Something that might be better, maybe, is we get around this by having AI learn and approximate our values through observation and implement. We basically be leveraging the AI's intelligence to learn what we want. If we don't know what we want, maybe the AI can learn it. Even if we don't explicitly say it. It just has to observe us and like, okay, I think this is what this guy likes. And they act accordingly. It's similar to how children would learn what the role model likes and work to make that role model happen. And this is still mostly theoretical. Much work still has to go into the technical process of evaluating. And the problem of aligning AI with literature is that we call alignment, which is quite a difficult problem to solve, since morality suffers from fragile transmission. How does one teach a stable and consistent morality to something that can alter itself? Remember that this is a super intelligent AI. It can change its own code. It should never be incentivized to change itself in such a way that its goals would end up misaligning with ours. Right? So that's a really tricky challenge. How do you build something that powerful yet still constrained? So that's a difficult problem. And it sounds almost impossible, but we just can't tell what we want, we really want. But I'm still hopeful. I have hope for the best. And good things may still happen. There are people working on AI alignment and research. And if things go well, we might end up with a scenario like this.
Yes, sir. Hold it down, sir. Hold your fire!
What's going on? I've brokered a peace agreement between the giant spiders and the government.
Thanks to the skill diplomacy of this mysterious spacecraft, from this day forward, human and spider kind will live side by side in peace. We will stop following them, and they will no longer use their telepathic abilities to make us wander into webs for later consumption. Instead, we will work together to make this world a better place for all, no matter how many legs.
What do we do about the space car?
Leave it alone. I mean, what did it really do anyways? Kill a guy and paralyze his body? Not a bad trade for spider peace.
All right, that's it.
I love this spider!
Summer is safe.
All right, I get it.
Yay, summer is safe. So, what will it take to get something, to get an outcome that's favorable? Well, let me present you a quote from the 80,000 Mars page on AI alignment. While billions are spent making AI more powerful, we estimate fewer than 100 people in the world are working on how to make AI safe. And so the challenge for us is to solve alignment before we reach artificial general intelligence. So artificial general intelligence is a difficult problem to solve. Making artificial general intelligence that is safe is slightly more difficult. So we want to be ready with a safety policy when we get there. For nuclear energy, we actually had something similar. We could have figured out controlled reactions before the atomic bomb, right? To use nuclear energy. The difference this time is that the stakes are much higher. When the intelligence bomb goes off, there's no, like, the stakes are just too high. And we could also add more resources to the problem, level up people. And we're actually very lucky, us, thinking about these things. We're very privileged. The chance to expand existential consciousness beyond ourselves or the tribes of the bigger country to the rest of humanity. And I do believe that we can work to extend this privilege to others. There's a saying that goes, there's thousands of Einsteins that are currently busy just trying to find food or preoccupied with meaning. And I strongly resonate with that belief. And so one way we can help solve these problems is to get more people on board. We can get more people on board by raising them up, solving their easier problems so that they can help us with the harder problems. And to lift people up, how do we do that? We use effective altruism. So you can use effective altruism to level people up and help them work on more important problems move forward. It's kind of a ripple effect. And even if people are lifted out of survival concerns, of course, it's no guarantee that they will gravitate towards these big challenges, which is why we sustain interest, unless we educate the public and talk about them, these things will go unsolved. So we foster public concern with discussion groups, following developments in AI, and social critique of new developments. Especially recommend spreading around the work that 80,000hours.org has done. And there's a lot of advice there on how to be more impactful with your career. There's a lot of good discussion going on there. So I'm going to start with a quote. A computer is just a rock that you trick into thinking. And so I think we must be careful to make sure that this rock does not trick us out. Thank you very much. Post-event survey at this link. I'll also be uploading my slides with a lot of additional resources. Thank you.
Thank you. Alright, so right now we'll have a few minutes for Q&A.
Yeah.
So if anyone has a question, a burning question, that was a really interesting talk. So if anyone has a question, the floor is now open. Make sure you have to raise it. Yeah, right.
Would you say in the...
That's right. Before you start, could you introduce yourself, maybe, and then background about it? It's alright. Here, next.
So scripted. Would you say to regulate the AI as for since existential risk, would you say yung actuation is like the biggest factor to it being a risk?
That's a good question. I think actuation is definitely a huge factor. The tricky thing is separating actuation with intelligence, because very intelligent creatures will find ways to, to actuate and improve their capacity for actuation. Think of people, right? I can't lift a huge rock, but I can build a machine that can lift a huge rock. So in the same way, once you get to a super intelligence, it's very hard to limit its actuation and predict what exactly it can actually move forward. There are many strategies that people try to think of, like, oh, well, we just put it in a virtual environment. It's in a box, quote unquote. But this is still pretty unsafe because something that is by definition smarter than you can probably trick you into letting it out of the box. It can pretend to malfunction. When you open the lid, boom, does some manipulation. So it's very hard to predict if the agent you're talking about is by definition a lot smarter than you. So, yeah, so thank you.
Are there any examples of AI agents that have figured out a sense of humor or how to lie?
Oh, a sense of humor or how to
Or
lie.
how humor or lying?
I'll have to look at, there's a very interesting research lab called HERB, Humor Research Lab.
Wow.
They use the humor in the thing. I'll have to get back to you on that, but they're one of the labs that I follow. They do a lot of interesting research on humor and how difficult it is to replicate, and different types of humor as well. Humor really is an interesting frontier for AI. I don't think they've been able to break that yet. As for lying, I don't know. I haven't seen. Oh my god! I can just imagine like a bunch of birds and adversarial setup, just trying to get into some system and get some information out of each other. I figure that might be a way to get them to start lying. At the moment, I don't have any information.
That's it. I remember I have a chat one visit where give me a joke today. And then you would just like instantly give me out jokes on the chat box. Any more questions? Yes.
So a lot of the talk is focused on like how AI safety is a huge problem and how it will affect them, it will affect us if we get it wrong. But what are the concrete ways in which we have been trying to prevent this sort of catastrophe from happening?
Okay. So there are many fronts, many parties that are trying to solve the AI invented loop problem. One of them is the Machine Intelligence Research Institute, MIRI for short, and then I think Eliezer Bukowski is part of this, and they're doing research on architecture, AI architecture, and the problem of teaching AI values. So getting it to behave the way we want it. So that's kind of a mix of engineering, math, and philosophy, where you're trying to encode morality into the machine. There are other attempts to mitigate our risks with regard to AI by integrating with digital technology before we hit artificial general intelligence. There's companies like Neuralink and others that are trying to make human-machine brain interfaces so that we can be digital natives and we can basically surf the internet using our minds and interact with computers far more effectively. And so that might help with mitigating the risk of AI dominating. So one of the things scares is the internet, right? If the AI gets into the internet, we're basically doomed. But if the internet is already full of human agents, then we might actually have more power to contain it. If our interface with digital equipment is still the keyboard and the mouse, we're hopeless. But if we're basically interacting with computers directly with the minds, we might have more of a chance. I don't think it's foolproof, but that's one of the things that people are considering. yeah, I think those are two of the most common political.
Hello?
Yeah.
This is EA, right? So like when you talk about like donating to these institutions, which institution do you think we should donate if ever we want to contribute to AI safety?
Okay. Well, personally, I think that Mir is going in the right direction. That the machine intelligence research is in. But I also wouldn't be averse to donating to 80,000 cars in general, because they also do a lot of the legwork in bringing AI alignment to the spotlight. So raising awareness with regard to AI alignment is as much a help as also directly addressing. So I guess those institutions I would probably support.
So the organizations that Pepe mentioned will speak more about it. Did you have a show of hands for doing AI already?
Oh, okay, machine learning.
Or machine learning?
I turned it machine learning.
Machine learning. Did you have, is there any, yes, yeah. Hindi, nakatayo. Yeah, do you have a question?
I really like how you present the talk, space, area, and the likes, and the proposed methods like advocacy, eat it before we get into it. But there's one major concern with that because the world is a big place. Remember, even if we have policies against nuclear war, we still have North Korea research about it, invading the path or the treaty of United Nations, right? So, what is good? The advocacy and scaring people. We're just things you can't control, you can't manipulate, for instance, the isolationist country, and knowing the fact that number one, every country wants to develop. So like there's a competition in the research, and you can't really tell like US, hey, stop AI development because it's like I know even China is stealing your data on your phones, right? So like there's no, I mean, the only way for us to do that is in sober. To advocate people to scare them in general.
Yeah, so I agree that it's difficult to tell people to slow down. And I think it's virtually impossible to tell people to slow down AI development. It's going to happen. People will develop AI because intelligence is just so data at solving problems. So I have no illusions of stopping that train. But what I want to do is build a cushion for that train before it hits the wall. Where does this train go? Anyway, the cushion is safety research, AI safety research. So like, we want to, instead of telling AI researchers to slow down or stop, which no, the better approach would be to help increase the number of people working on AI safety and the alignment problem. So we want to just speed that up so that we can have a safe landing of artificial general intelligence when we get to it.
Thank you for that comment.
I have a question about since there's been some research about adults speak of any
Okay.
so it has been an ongoing discussion even though so we want to know at what point we allow AI to participate especially in competitions like international.
Yeah.
So there's been a lot of it's actually there's been a bit of research that should be allowed to So actually, I want to get that question as very interesting.
Yeah. So that's very interesting. Like how AI, the rise of AI like changes our relationship to games, right? Because we used to think of opponents as just people, but now we're open to playing against artificial intelligence. And it used to be that, oh, you're just playing against AI. But now, like, the AI is better than people as well. You're playing against the AI. It's changed so much in just a span of a few years. And so it's really interesting how AI changes our relationship to games. And in particular, with Go, for example, the AI has been exhibiting behavior that's novel to us. It's actually been teaching us new techniques on how to play the game. So I think it's fine. It's going to be up to people to decide if they want to play against AI. I think they will get better if they do play against AI. They might get so frustrated if the AI is too much better than them. There's also the question of, would you want to tone down the AI so that you have more of an even match? You know, that might be an offer. I want to play a fair game today. Or I want to play a game where I utterly destroy the AI. Or I want to play a game where I am super challenged. So you can even have that kind of control over the difficulty of your games now. So I guess it's up for each and every gamer to decide whether they want to play against the AI and have that control. But I think it's definitely interesting how we've started learning from the AI. And I think one of the trends that will keep growing is spectator gaming. Like spectator gaming has been growing quite a lot, right? With Twitch TV and a lot of the streamers. But I think we might be at a point where AI might be interesting enough to just spectate. AI matches against each other. Now that might be a relatively select crowd of maybe emotionless people, because people like to listen. People like to watch streamers because they relate to the streamers. Like the people that they interact with, they chat with them, right? So I think the next step is to build a streamer AI that can actually talk to you on chat and like crack jokes. Thank you for subscribing. To that kind of interaction. Yeah, I think that's something interesting to solve. Yes.
So when we're talking about like how humans build apps, building structures,
Yeah.
With the inevitability that AI within the development of general artificial intelligence, they actually can have more power with us in terms of intelligence. How are we as a decent race are supposed to survive so that we can survive as a species?
That's a very, very good question. So there's many views on the possible future that we have, post artificial general intelligence. Well, a safe artificial general intelligence. If we don't get there, we're soon. But if we do get a safe artificial general intelligence, some people think that we might be able to control them and become something like godlike, by just thinking of things and have this artificial general intelligence realize it for us. Basically, instantly enforce our values onto the world. There's also people who think that, well, no, let's not limit the artificial general intelligence. Let's let it take the wheel. Let it actually expand, but keep us safe. Kind of like pets. So some people think like, we can live pretty sweet lives, just, lounging around, playing like a giant Burning Man across the planet, a giant party, the AI taking care of all of our needs, while the AI expands across the galaxy and, solves the mysteries of the universe, while we're just partying. So that's kind of a hedonistic view for the future. So there's different approaches to that kind of scenario. Personally, I don't know. I kind of like that Burning Man Thinking can get pretty tired.
Guess we have time for at least two more questions. Yes, Nico?
Regarding the alignment problem, you showed the diagram a while ago that it shows the values and like the trait values like that. I think about this problem a lot, but we have like 8 billion people. I don't know, like the solution that comes to mind is consolidating the values. But I don't think that's even possible with people. Are there institutions that are like trying to go for like less utopian solutions, or do you have anything in your mind that it's a rough sketch of not having to consolidate your values?
Yeah. So like this kind of falls into like group decision theory space, where it's really like one-on-one situations, morality can be pretty straightforward, right? And the moment you add groups there, it gets super blurry because there's so many contradictions that can come up with every rule that you can think of. So I'm not really aware of like I'm guessing these would be philosophical think tanks working on this kind of problem, a consolidated morality. But yeah, it's tough. sorry, I don't have a better answer. I would just, I think I would look into which resources would I point to. Well, I guess I would explore Paul Bloom's work on moral psychology. I think that's one very interesting course that you could take online and probably find inspiration for solutions there. But past that, I don't have questions.
Yeah, so it's sort of connected to what Nico was talking about with like morality and the alignment problem. So a lot of our discussions now is more of like thinking about the alignment problem in the context of like AGI, artificial general intelligence. But like one perspective of AGI, right, is that this like completely all-knowing algorithm is actually a collection of like smaller pieces of algorithms that are actually task-specific.
Yeah.
And so if you're actually looking at industry now, there are actually a bunch of situations where it's not an AGI, but a very task-specific AI model that has its own set of moral dilemmas. Like for example, like we now have like algorithms that are scoring, generating credit scores for people.
Yeah.
And so like, right, it's a classic problem of how do you make sure it's not just profiling someone based on race and those kinds of things. And there are actually like full fields of study that are focusing on how to make it stop being racist. And so the interesting thing about that is that it's not just, I mean, ideally it's altruistic in the sense that, oh, they're just trying to be good people. But a lot of the time, they're forced to do this because of like regulation, like telling them you can't deploy that thing unless we can make sure that it's not being racist. And so like I think that has some, like I was wondering if you have thoughts around that, and I think that has a lot of implications in terms of like how we can scalably regulate this thing. Because like one perspective is let's look further away and regulate AGI assuming it happens. Or we can go more micro, and why don't we apply this sort of alignment problem to like smaller tasks?
Yeah.
Forward.
Yeah, that's very interesting. I think kind of the corollary of the alignment problem is something called subsystem misalignment, which is the other way around, where an intelligent creature creates subsystems that are somewhat intelligent, but inadvertently these intelligent subsystems are somewhat misaligned with the larger creature's bigger objectives. Right? That's also actually another open problem that is interesting and people might want to look into. And it's not, what's funny is it's not limited to just artificial intelligence. Even us and our brains, we already have subsystem misalignment. Like, just we want to eat healthy, but sometimes donuts. Right? There's subsystems in our brain that are not aligned with this bigger system. So that kind of delegation problem props up with all types of delegation.
Okay, so that's our last question. Thank you so much. And we have a small gift for Pepe from, and I'll let Brian share this. Okay, nakita na yan.
I'll just act surprised.
Just act surprised.
We have a surprise.
Oh, yay!
Okay, so I usually when we have speakers come over to Effective Altruism Philippines for talks, we give them a token, which is usually a book, and this book, Human Compatible. Does anyone here know about this book? Yes, so okay, 4 people here know about this. That's pretty cool. So this book was only released last month. So it's the newest book of Stuart Russell. He's the head of Center for Human Compatible AI in Berkeley. It's like one of the leading research institutions working on AI alignment, I believe. And so I bought this last week and for Pepe, but since I had the book first, I decided to read through it. I was able to read 85% of it. And it's really amazing, and it's actually very readable even for non-AI researchers, non-AI people who aren't that familiar with AI. So we also have one more copy of this, which we will be raffling off to anyone who might want to read it later. So yeah, here you go.
So thank you again. Yes.